Okay, this is how to find the two half equations given a whole equation. Okay, this is complex, clearly whole equation. You can see here you've got chromium in this compound, and then you get chromium ions after. So if we start with that, we've got our chromium. This is dichromate, it's called, and chromium ions. So is it a reduction or an oxidation reaction, this one? So we need to use our oxidation numbers. So if we work it out, so it's oxygen's -2, we've got 7 of them, so it's -14. This dichromate has the whole thing, I should have it in brackets, has a 2- charge, so we need something that we add to that so that we've got 2 negatives left over. So if we add 12, so that's divided between 2, so each chromium is +6. So this one is the same as the charge on the iron, so it's +3. So chromium has gone from +6 down to +3. So it's gained negatives, it's been reduced. Each chromium has had to get 3 electrons. There's 2 chromiums, so altogether you need 6 electrons. So that's balanced our charge, but we would need to, and we know it's a reduction reaction, but if we do it the long way, we need to balance everything except the oxygen first. So the first thing we really need to do the other way is balance. We've got 2 chromiums, so we're going to need 2 chromiums. And then we balance the oxygen by adding water. We've got 7 oxygen, so we're going to have to add 7 water molecules. By doing that, we've added the hydrogen, so 7 lots of 2, we've added 14 hydrogen. Remember the H plus here. Now if we look at the overall charge, we've got 2 negatives and 14 positives. 2 negatives, 14 positives, and on this side we've got 2 lots of 3, so we've got 6 positives. 2 negatives and 14 positives altogether make 12 positive. And 2 lots of 3, 6. So we've got 12 positives so far and 6 positives on this side. So we need to add electrons so that we have the same number. So we'll need to add 6 negatives on this side so that we have 6 positives on that side as well as on this side. So this is our reduction reaction. So the chromium here going to this is a reduction reaction. So this one, we've got 2 carbons, and it's an OH, so it's an alcohol, and it's ethanol. So we're going from ethanol to, this is a carboxylic acid, because there's 2, ethanoic acid. So we're going from ethanol to ethanoic acid. And these hydrogens and water are part of the whole balancing of this reaction. So we'll just get our ethanol and our ethanoic acid and do a complex half equation for it. It's easier to use how many carbons, hydrogens and oxygens. So if we just turn that semi-structural formula into just a straight formula, it'll be easier to work with. Okay, so the first thing, we have to balance everything except our carbons and our hydrogens and oxygens. So we've got 2 carbons on each side, that's balanced. Balance the water by balance the oxygen by adding water. We've got 2 oxygens on this side and only 1 on that side, so we'll have to add water. Now we have to balance the hydrogens. So on this side we've got 6 and 2. We've got 8 hydrogens altogether over here, but only 4 over here. So we'll need to add 4 hydrogens more. So by adding hydrogen ions. Then the last thing that we have to do is make sure the charges are balanced overall. There's no charges here, so we need to add 4 negative electrons to balance out those 4 hydrogens. Okay, so this is clearly oxidation reaction because the electrons are on this side, they're being lost. So our 2 half equations, this is the chromate, dichromate, and the oxygen. What am I saying? The oxidation reaction. Okay, if you put these 2 reactions back together, we'll get this one at the top. So let's see if we can do that. am I doing that? I'm not sure. We've got 6 electrons here and 4 electrons here. So the first thing that you have to do is make sure you have the same number of electrons gained as lost. So 6 and 4, the number that they both go into most easily is 12. So if we double that, we'll get 12, and if we triple this, we'll get 12. So because there's huge numbers of things to play around with, rather than doing it as I go, I've just done them both. Okay, then we just collect everything on the left and write it out, and everything on the right and write it out. So when we collect them, it's huge, as you can see. So now we have to go about trying to simplify it. We've got 12 electrons here, 12 electrons here. That's the first thing that we need to do, get rid of them. We've got 28 hydrogens on this side and 12. I'm not sure if I did that first. So we need this, get rid of some. So we can get rid of 12 from this side and 12 from that side. Did I do that first? Yes. 12 from this side, 12 from that side. So we'll have 12 of this is 16 left. We've totally got rid of all of those. And then we've got 3 waters on this side and 14 waters on that side. So if we get rid of 3 from each side, then we'll have 11 on that side. And that should bring us back to the original equation.